Next up, we have Clive Chan, Principal Solution Architect at Openhive. How are you doing? Hope you're doing
Hi,
well.
good. Can you hear me, Simon? Yeah,
Yes,
good.
yes, I can hear you. I can hear you. So Clive is here to talk about creating value and insight through privacy-preserving data collaboration with federated learning. So I'll hand it right over to you, and
Thanks,
we'll get
Simon.
started.
Yeah,
Thank you.
yeah. Let's get started. So, good morning, good evening, or good afternoon, everybody. My name is Clive Chan. I'm from Openhive. So today I want to share how our technology can help companies or individuals to create value and insight through privacy preserving data collaboration with federated learning. So my company, Openhive, actually is a technology brand that focus on privacy preserving data collaboration. So let me talk about what is privacy data collaboration. So actually, we would like to leverage our technology to unleash your data value through data collaboration. Um, This is what we call the power of access, that our company would like to share the technology to the ecosystem to co-create a new data era together. So this kind of value proposition vision for our company. We want to provide the technology and connect the different party through API data collaboration to find co-create more values. So OpenHive solution, actually our team is leverage a lot of technology from the open source. So this actually this all technology is from the large top global digital bank awarded by Asia Banker. So the two main core technology that we use in our solution is these two open source project. One is what we call Faith, is more focused on AI and machine learning while preserving privacy, and that's the topic I'm going to share today. This project and how we on top of that have our enterprise offering to help the ecosystem. Another one is our blockchain solution that we call a physical Bitcoin. So actually, this is a blockchain project that very famous in mainland China. And on top of that, we do a lot of privacy enhancing technology to help the ecosystem to share data on top of that. So all these technologies come from the top global digital bank that established since 2014. And this because the bank is a 100% digital bank. So we're the largest digital bank and serve a lot of customer. Underlying, we have a big team of IT staff. We talk about over 50% of our staff is technology staff. So with this experience, technology, our data-driven business, we want to share the technology to the community, empower and enable the ecosystem such that more people can connect it together through data collaboration, through our federated learning or blockchain technology to build insight and value. So that's why we're here today to share what we did in Hong Kong, what we did on top of that open source technology that help the ecosystem to build more insights and more value. So actually, why we're talking about privacy enhancing data collaboration, Gartner this year in the 12 top strategic trend, they say that one of the top trend is a privacy enhancing computation technology that help organization to share data. So they predicted that around 2035, more than 60% of large organizations will use one or more privacy enhancing computation technique in analytics, in business intelligence, or in cloud computing. So actually, privacy enhancing computation are a large umbrella of technology. And underneath, they have a lot of technique to help company to preserve privacy and while working on processing of data. So in the definition of Gartner, they're saying that a privacy enhancing computation is allowed approach that allow data to be shared across ecosystem, creating value but preserving privacy. I think this is a very uh, good definition on privacy enhancing computation, and the trend of a lot of country regulatory body, they saying that privacy is a top priority for them, and personal information should keep very good process or governance to be followed. So there's a lot of regulation like GDPR in China, there are privacy law. In Hong Kong, there's also a lot of law to govern all this privacy of the usage of data or personal data. So when company they want to collaborate together, they have to be very sensitive or very put effort to preserve the privacy while they working across the data, across the ecosystem. So with that, actually this technology is not quite new. Actually, this technology is still evolving, and in the first generation of this kind of privacy enhancing computation is around 1979 that people they talk about how to do the secret sharing. That means I won't share the values of my data, but we can do the computation together while keeping the secret of the values. We'll do some average or some calculation. But this kind of privacy enhancing computation or secure multi-party computation are not quite easy to generalize to different mathematical operation. So that we come to the second generation of this kind of technology we call a trusted execution environment. There's a dedicated software and hardware so that data which will inject in this environment. Different organizations they can't see the data of other party, but they do the computation together. But there's also a challenge of having to inject or putting all the data to a centralized environment or platform to the computation. And on top of that, the mathematical operation is not very easy to generalize to typical use cases. So for that generation of technology, they come to the third generation. So in 2016, Google, they come with an idea called the horizontal federated learning. So in every Google keyboard, they could share the partial model to the centralized server, and they can aggregate the result to improve the model. And then with the aggregated model, they can push down improve the model to the individual device. So such that there are no transfer of raw data of what you're typing, but Google can improve the prediction model using horizontal federated learning. They kind of aggregate the model in their environment. So this one kind of the privacy enhancing computation that could help model building without sharing the data. So in 2018, we Professor Yang also have an idea called vertical federated learning, and this is the technique that I want to share more today. With this technique, organization like bank or other company like insurance company, they can leverage the feature or parameters from their data partner, or we call the data provider, and they can do the joint model training. But the data provider, they don't have to share the raw data or the PI information to the bank or to the insurance company, and they will process the data locally with the encryption technique that I will share later on, such that they can co-build a machine learning model, do the prediction while preserving the data privacy. So with this, and this year, Professor also evolved the privacy enhancing computation we call a trusted FL, trusted federated combined blockchain, other technique to make sure the integrity, the model training, and the security, such that the data party that collaborate together, they will be protected with the model training and parameter on the data. So with the third generation of federated learning technique, more companies will enjoy the data collaboration and get insight from this kind of model training and the collaboration. So actually, what's in detail what's a federated learning and what's our solution to help company to do all this joint model training or data collaboration. So actually, the business use case is quite straightforward. A lot of our company they moving on using API, using data collaboration, using a lot of different technique to improve their data-driven business model. When we talk about data-driven, a lot of companies will want to acquire more data. We call this alternative data, because a company, they like a bank, they only have the data of their customer transaction, the account, or they can only get the data from the credit bureau, but they can't get alternative data from other organizations like telco, like e-commerce, like a loyalty program. So how can a company like bank or insurance, they move into data-driven, acquire more data to improve understand their customer behavior and the prospecting. So they would like to have more data, but in the real situation, they don't have sufficient data. So with this, traditional machine learning was saying that, hey, you have to pull all the data in a centralized platform to do the analytics, to do the machine learning. But this, actually violate the regulation, the law that I said before, GDPR or other compliance law that are imposed in different countries. So with federated learning, I said before, because it's a distributed machine learning, multi-party, they can collaboratively do the modeling in a distributed manner, while data is residing at their source. So no raw data or a PI information have to pass to the counterpart to do the training. So they don't have to have a centralized location and avoid security risk in the transit. And therefore, companies they can leverage this federated learning concept to do cross-country, cross-region joint modeling at the presentation at the below, or they can collaborate with like a bank. They can collaborate with an insurance company to do the bank insurance use cases, or even a company like an insurance company, they can work with data provider like a telco or like a electric car or company to get some IoT data to improve their propensity or the claim, the modeling. There's other use cases that company can do this, or even maybe there's a operator, the host or the company, the data provider and the data requester together to share, to build an ecosystem such that company can choose and pick the data from different providers to build a machine learning model. There's also could help company, they don't have to use a traditional machine learning model while they can gain insight and value using a federated learning, and all the data will be distributed across different organizations. So I said before, this is a third generation kind of privacy enhancing technologies. And there's two categories of categorization of federated learning. The first one is a horizontal federated learning that promoted by Google. It's kind of an aggregate or stacking of the data sample because maybe some organizations, they have not enough data sample, they can acquire a similar data set with similar feature from counterpart. Usually they will, within the same industry, like a bank, they want to have improved their AML or fraud detection model. They can collaborate with different banks because the fraud case is not that often happen, so that they can aggregate the data set and do the horizontal federated learning. So we aggregate the ID. And other use cases is we talking about using the vertical federated learning. We let's say in the diagram here, the bank, they have the labels, they have their feature. They want to aggregate the feature from data from the company like company C, such that they can expand their feature set while preserve the privacy and do the joint modeling with the counterpart like different data provider they work on. So these are other kind of federated learning model we call vertical federated learning. So bank or insurance company, they could expand their feature set to do the machine learning. So actually, this is some of the use cases that we found in the insurance company. Actually, this is from we insurance company saying that, hey, because we have a lot of different data in a data silo kind of concept, they can't be centralized in a central place. So they want to break the data silo. So for insurance company, they only have the insurance data like the in-force policy, claim history, their sales channel data or some of the sales campaign data, they would like to acquire alternative data like online browsing, IoT as a wearable, fitness data, social media, such that with this additional feature using vertical feeder learning, they can build model like propensity to buy, improve their risk score model, propensity care model, so that such that they can have a enhanced AI model. And with this enhanced AI model, they can do personal pricing more effective to predict the customer behavior. So actually, further learning can leverage on that to significantly improve model prediction. A lot of different industry looking for this kind of use cases as well. So in more technical term, how federated learning to preserve data privacy during the collaborative modeling. Actually, they involve three parts. The first is intersection of the data. As I said before, because the bank or insurance company, they request the data from the alternative data provider. So they have to first identify their common IDs and common data set they could use for the joint modeling. And with this, we use PSI, we call private set intersection technique with the RSA encryption or DH encryption on top of a hashed ID, just a pre-agreed ID, such that the bank and the data provider, they could find a common feature set for the training. And each party, they would train the data locally using a homomorphic encryption. And what the share across the party, just the intermediate result is the gradients and partial laws kind of thing that they will fine tune during the model training. And all this training will running on top using a homomorphic encryption, such that no raw data will be passed exchange across two parties. Once the model is trained and optimized, they can do the prediction using the partial score, such that there's also no raw and PI information to share across two parties. And this how bank insurance to collaborate joint model with the data provider and no exchange of PII and raw information. So what is a homomorphic encryption? Actually, homomorphic encryption is a property of some encryption scheme such that you can compute on the ciphertext as the diagram shown here. Let's say I have some additive function. You want to do the additive function like 5 plus 10. So actually, in traditional sense, you have to do it in a clear text. But using homomorphic encryption, we can use the public key to encrypt the clear text and pass it to another party. And the other party can use the ciphertext and the corresponding encryption function in the clear text is the additive function to do a add of two ciphertexts. And in the end, the outcome is another ciphertext. But with the private key, the other party can decrypt the ciphertext, and with the result of the clear text is 15. So with homomorphic encryption, with a machine learning algo that we develop, we can distribute the loss function, the computation to two parties, and each party will compute on the ciphertext only. And with the computation, they can find the gradient, can compute the cost and the loss function and optimize the algo distributed. And finally, the party will have the partial weight for the corresponding feature set, such that the bank will have their feature and they have the algo corresponding parameters. And for the data provider, they will have their feature set corresponding parameter and keep in their organization. When they do the prediction, they will compute the partial result, and then the data requested the bank or insurance company, they will add up and do the final score. So with homomorphic encryption, data will be computed in an encrypted fashion. Share is just the intermediate result. So the privacy is preserved and data modeling could be done. So this is the beauty of federated learning. And a lot of companies were looking for the use cases, how they could use this technology to collaborate, finding insight with their counterpart. So actually, one of the use cases ourselves, as I said before, we are 100% digital bank, and we want to help to serve the underbanked or unbanked SME. But that kind of SME, they don't have a lot of financial statement or credit history that we can leverage on to do the proof of the loan or how much we can approve for that particular customer. So with federated learning, we leverage alternative data from other data provider like large invoice data company. So their data will keep in their premises, but we leverage the additional feature set data and to do our SME credit modeling and to do our credit scoring for this kind of underbanked SME. So with this, we can improve our loan performance and handle the credit data shortage issue, and we can promote the inclusive finance for SME in mainland China. So this is one of the proven use cases that we did in China. So with this success, we want to enable and empower the economy and the ecosystem in Hong Kong. So last year, we collaborate with Hong Kong Science Park and Technology Park, and we work with three bank in Hong Kong, Bank of China, HSBC, and Hang Seng Bank, and we did a pilot project with them to see how federal learning could predict a bankruptcy model with data that distributed across different parties. So in this project, we successfully built a distributed machine learning model, keeping privacy, and as I said here, you can see the AUC for the model review, and there's a top data scientist. They use the same data set and do the AUC is talking about for the OOT is 93.5% of the AUC result. With federated learning, we separate the data into three features set, and then we obtain the same AUC such that we preserve the privacy, we prove the algo is lossless, and the bank is very interested and looking forward for the actual use case that could be used in the future. So for this use case, actually, Hong Kong Science also have a press release saying that this is the first time that the federated learning networks have been deployed in Hong Kong, and technology powered by the technology that I said before, built on the open source Faith project. But on top of that, we put a lot of API security for the enterprise to consume the underlying algorithm much more easier, such that they could use the API for the data ingestion. They could use just for the API for the prediction, for the all kind of usage. They don't handle the underneath a lot of the compressed, algo parameters. They just ingest API, and then they can get the prediction result with a JSON file. So this is kind of a platform we help to build, and we also improve the API such that they are more security, they are more automation apart from the original kind of open source project. So this project also we have kind of adoption from the Hong Kong MA. So this year in April, they published a RegTech adoption practice leverage the use case we mentioned before, the federal technology to enable bankruptcy detection. So they also have a kind of sharing, saying that, hey, for the industry, federal learning is a kind of tech that can help data sharing while preserve privacy. And also in Hong Kong, the data protection principle, the personal data privacy ordinance also recommend using this technique to mitigate the data risk, privacy risk. So using federated learning can train AI model as to avoid unnecessary sharing of training data from different sources. So there's a kind of signal that the regulator and the law is kind of saying that federated learning is a technique to help to build the ecosystem while preserve privacy. So our solution, as I said before, we build on top of open source. So it's an enterprise solution. We build on top of a lot of API for data exchange, a lot of API for prediction, a lot of API for injection, such that you don't have to very difficult to use this solution with a very easy to use, ready to use with all the API for you to do the training and the prediction. Largely, I was saying that with this potential technology in Hong Kong, I'm saying that we are the technology provider. We have built a solution, and different data requests like bank or insurance company, they can collaborate with a potential data provider, and such data provider could be alternative data source like credit bureau, payments, retail, e-commerce, travel, telco. And on top of that, company like startup, they could help to do all the operate this kind of collaboration, like how to do the data cleansing, how to do the agreement on top of the data matching key, thing like that. And on top of that, you can leverage our solution to provide data scientist services. So with this ecosystem, I think there's a lot of opportunity for bank, for insurance model requester, or for data provider to monetize their values. For other startup company, they can leverage our solution and push it to help different parties to collaborate together. So that's all for my presentation today. Hope that with our technology, we could create a new data era that help collecting different people while preserve privacy, and data can be finding more insight. Yeah.
Yeah. Thank you so much, Clive, for your insightful presentation. It was very interesting. Unfortunately, we have run out of time for Q&A.
Okay.
So I thank you for your presentation, and I hope that you have a good day.
Okay, thank you. Thank you, Simon. Thank you.
Bye-bye.
Bye-bye.
Thank you.